Hello everyone, welcome back to my channel. This video is basically the continuation from the last video. If you haven't seen that video, please go and see it. I have attached the link into the description. In this video, first we are going to take a recap from the last video, the learnings which we had from the last video. Then we'll cover the next phase of migration and the different strategies used by Netflix for this purpose. We will also cover how to migrate persistent stores, basically how Netflix migrates the persistent stores in their system. Okay, let's start. In the last video, we majorly covered replay traffic testing. Let's see how replay traffic testing works. Suppose existing service is needed to be replaced by a replacement service. In this, entire production traffic is cloned and with the existing service is also sent to the replacement service asynchronously. Then in down the line, responses from both the services are recorded and compared. And after comparison, certain validation metrics are generated. These validation metrics tells Netflix how accurate the replacement service is, whether it is required some fine tuning or it is safe to roll out to the production. So, replay traffic testing provides an initial foundation of validation. For the complete rollout, Netflix needed a carefully controlled migration process, a process that minimizes the risk, also facilitates a continuous evaluation of the rollout's impact. For this, Netflix uses different strategies. Let's learn one by one all the strategies which are used by Netflix for migrating the traffic in the production. So the first strategy which Netflix uses is Canary Deployment. Let me tell you a background story about Canary Deployment. एक कैनरी बर्ड होता है जो हार्मफुल गैसेस से काफ़ी सेंसिटिव होता है, तो जो हमारे कोल माइनर्स होते थे वो इस कैनरी बर्ड को अपने साथ कोल माइंस में ले जाते थे टू डिटेक्ट ऑल द हार्मफुल गैसेस लाइक CO2 एक्सेट्रा. सो वो उनको डेंजर से बचा लेती थी. सिमिलर टू दिस, Canary deployment is basically a technique which reduces the risk of rolling out a new version of any service into the production. This strategy is widely used by most of the companies, but each company has its own version. Okay, let's see how Netflix uses Canary deployment. So Netflix creates two new clusters. One is baseline cluster, one is Canary cluster. Canary is going to have the new version of the service, and baseline is basically the existing service which is a copy of the production service with the same configuration. Okay, now when the production traffic comes, router decides where to send the request. Either the request will go to the existing production cluster, or either the request will go simultaneously to both the baseline cluster or the Canary cluster. Only a very small amount of traffic is redirected to baseline and Canary clusters. Then again same, the metrics are generated and lot of analysis is done to figure out how the service is performing at this stage. Okay, so what is the need of baseline cluster? Why Netflix creates a same copy of production cluster? The only difference is production clusters have many servers which serves the entire production traffic of Netflix. Baseline cluster generally have only 3 servers, same as Canary cluster. It also have only 3 servers at max. Okay, so Netflix had a thought process that Netflix wanted to ensure that the metrics produced are free from any effects caused by the long running process. Basically the existing cluster is running from very long time. Basically the Netflix wanted to make sure that the metrics which are being generated for the analysis are free from the any long running process. That is why Netflix creates a copy of production cluster. When I say copy, it's like the same configuration as the production cluster. Now there is a limitation in Canary deployment, is that let's say if I am the same user which first accesses the Netflix, router decides let's send my request to the production service, but later when I second time I requested, now router decides randomly, okay, now send my request to the baseline and Canary cluster. Okay, so basically here all the metrics are stored on the individual service basis. But in the production, lot of features are not owned by a single service, but a series of services. Basically, one service calls another service, then another service. Let's take an example like video playback functionality at Netflix. The first step is to request URL for the streams from a service. The second step is to call CDN to download the bits. The third step is to basically request a license from a separate service to decrypt the bits, then sending the telemetry. So basically all the production features are run end to end by a series of services, while Canary Deployment only analyze the individual service because randomly router is deciding either to send the traffic to production cluster or either send the traffic to the Canary and baseline clusters. So to overcome the limitation of Canary deployment, Netflix uses an advanced version of Canary deployment, that is sticky canaries. Okay, so this is basically an improvement of traditional Canary process. What happened in this? That a pool of customer devices is created. Okay, so whenever a request comes, if the customer device belongs to that pool, then the router will always send that request to baseline cluster and the Canary cluster. Okay, then these metrics are generated and Canary analysis done on those responses. And here Netflix sees whether the new service which is deployed in Canary is meeting the performance criteria like latency and etc. Okay, if the device does not belong to the Canary pool which we created, then the request will go to the production server to serve the request. Basically, sticky Canary stores and analyze both the individual service level metrics, also the both broader customer and business level metrics to decide how the new service is performing. So compared to replay traffic testing, Canary deployment has following advantages. Basically, it allows us to extend a validation scope beyond individual service level. It provides a confidence that migration will not cause any disruption to the customer quality of experience. Also provides an opportunity to measure customer performance under different load conditions. This is done by recalibrating vertical and horizontal scale factors and increasing the customer device pool. Okay, the pool which we are created. It also enables us to further fine-tune the system to make sure that changes are integrated smoothly and seamlessly. So after replay traffic testing and Canary analysis, if Netflix sees that the new version of the service is fit to roll out to the production, in certain scenarios, in very specific scenarios, Netflix test another layer of testing that is called A/B testing. A/B testing is also a widely used method for verifying hypotheses through a control experiment. Okay, in this, the production users are categorized into two groups, group 1 and group 2. Group 1 requests are sent to the existing service and group 2 requests are sent to the new service. Then responses are recorded from both the services and analysis is done. So basically A/B testing helps Netflix to limit the exposure to the migrated system because it is exposed only to group 2 and which could be very minimal set of users, thereby controlling the risk of unexpected behavior resulting from the new changes. Okay. Also, A/B testing is a key technique in migration where updates to the architecture involves changing the contracts as well. Basically, if the SLAs, service level agreements, are being changed between two services, here A/B testing plays a critical role. So Canary experiments are typically conducted over periods ranging from hours to days. But certain scenarios may require longer experiments, like measuring a specific quality of experience metrics. For example, business thinks that enhancement in playback quality will cause more users to engage with the play button. Okay, so A/B testing helps in this next level of confidence building process. Other than this, A/B testing also helps us. Like for example, the test group can be created based on geography, based on device platform, or based on device version. This ensures that changes do not impact specific customer segments. Okay. As I mentioned that in Netflix, A/B testing is not used in every migration, but where the changes are expected to impact device quality of experience or business KPIs significantly. So after getting the confidence that new service is fit to roll out to the production, now here comes actual rolling out process. Okay, for this Netflix uses a software called Dial. Okay, it has two major components. One is a dynamic property called desired percentage. It can be configured from a configuration portal. Like initially it could be 1%, then it could be 5, then it could be 10, and so on. Okay, then there another component, that is distribution logic. It decides whether the request is going to fall in the range of the desired percentage or not. If it is in range, then the request will be redirected to the new service, otherwise request will be served from the existing service. Okay, this distribution logic use key parameters in the request, that it could be based on the timestamp on random number. Also, if Netflix wants that the specific device request should always be redirected to the new service or existing service, then this distribution logic can be based on the device ID. These dials can be applied anywhere, like in the device application code, in the relevant server component, or API gateway for API edge API systems. Okay, this makes dial as a versatile tool for managing migration in the complex system. Okay, so basically using dials, traffic is dialed into the new system in a measured discrete steps. Like initially it could be 1%, then 10%, then 15%, then direct on 50%, right? Okay, so these each call one step, and at every step relevant stakeholders are informed and key metrics are monitored to make sure everything is working till this stage and it is safe to roll out to the next stage. Okay, now dialing step can also be scoped at the data center level. Like only one particular data center traffic will be redirected to the new service, and all other data center traffic will be redirected to only existing service. So this makes easier side by side comparison of key metrics across data centers. Okay, and duration of each dialing step can also be adjusted. Like for example, in 1%, then Netflix want to stay like for 5 days, then for 10% Netflix only want to stay that only for 2 days because all metrics are working fine. Then we are moving to 50%, Netflix wants to stay here for 50 days. So each dialing step can be adjusted. Now let's understand how Netflix migrates persistent data stores. The strategy used by Netflix might not be applicable to all the persistent stores migration, because for most of the Netflix databases, data model is very simple, self-contained, immutable, and with no relational aspects. Basically, for most of the databases, Netflix doesn't require strict consistency guarantee, also does not use transaction. So that strategy Netflix use is called ETL based dual write strategy. It has following stages. First one is initial load through ETL process, in which the data from the old data store is extracted from a offline timer job and written to the new data store. In step 2, so whenever there is a request in the Netflix, so Netflix uses active dual write strategy and a dial based on the device ID. So whenever the request comes through an active strategy, data is written to both the data stores, old data stores and new data stores, and dial here, and dial is basically controls how much traffic should go to new data store, but dial is based on device ID to make sure that all the requests from a same device always write to both the data stores. Otherwise, there will be inconsistency. So basically, for a single device, all the state altering request writes the data into the both the data stores. Now, third stage is continuous verification of records. So whenever there is a read request, the service reads the data from both the data stores and compares it for completeness. If service is latency sensitive, then this process can be delegated. This comparison process can be delegated to a offline timer job. Otherwise, it can be compared for completeness in the real time. Then in the fourth stage, evaluation of migration completeness. So basically here Netflix has cold storage facilities which takes dumps regularly from the old data store and new data stores and verify for the completeness. If there is any gap, then through the same timer job which we have used in the step 1, it's used to fill those gaps. Once we get the confidence and the migration is completed, then old data store is deleted and all the request is redirected to the new data stores, and all the data stores, all the old data store is cleaned up and all the resources are freed. So the final stage of migration is cleanup, and it is very important. So basically, once the migration is complete and validated, all the migration related code such as traffic dials, A/B test, replay traffic integration can be safely removed. And Netflix also documents the entire migration process and also keep records of any issues encountered and their resolution to smoothen the rollout or migration in the future. Okay, so basically at Netflix, all the efforts had largely successful with minimal and no downtime. If you love the whiteboard style explanation, please like the video, and in the comment section please provide your suggestion on what topic I should cover next, also on what area I should improve. If you want more tech videos, please subscribe to my channel. Thank you.